Hi, this is Guntuka Srinivas, Civil Engineering faculty. I welcome you all for the GATE and IES online classes. In this section, let us have a glance over the geotechnical engineering. The geotechnical engineering subject consists of two parts. One is soil mechanics and the other is foundation engineering. As far as GATE exam is concerned, this subject is having a weightage of 14 marks to 17 marks. A minimum of 14 marks and maximum up to the 17 marks. If you look the trend of previous question papers associated with the GATE examination. In this session, let us concentrate on the fundamental aspects of the geotechnical engineering. Geotechnical engineering consists of two parts. One is soil mechanics and the other is foundation engineering. These are the two parts associated with the geotechnical engineering. Observe here. If you look the ground, this is the ground level, and all these are the particles. This is completely the soil mass. Below the ground level, everything is the soil mass. And this soil mass is a load-bearing material. Soil mass is a load-bearing material. That means whatever the structure you construct, starting from the building to a big dam, a reservoir, or else an industrial structure, a flyover, a road, whatever it may be. Any civil engineering structure, if you are going to construct, the load is completely borne by the soil mass below the ground. Is it clear? That's why it is very, very essential to take care of this soil mass in designing aspects. Is it clear? Now, observe carefully. Soil is a particulate system. So, this soil is a particulate system. Particulate system in the sense it consists of the soil consists of particles. All these are the particles. Mass consists of the particles. These are all soil particles. Record. These are soil particles. And there are gaps among those particles, empty space, gaps among those particles. Those are known as voids. Those gaps are known as voids. That means if you take a dry soil mass, it consists of all the soil particles. And there are some gaps among them. Those gaps are known as voids. That means here I conclude that dry soil mass, dry soil mass, dry soil mass is a two-phase system. Is a two-phase system. Why it is a two-phase system? Why it is a two-phase system? Because it is having only two parts. One is having the particles, the other are the voids in the dry soil. Clear? Voids may be filled with the air inside, but there are only two things: soil and voids. Hence, this is known as two-phase system. Is it clear? Now, observe this. This soil mass is originated from the weathering of rocks. Weathering of rocks. Okay. Whatever we are speaking about the soil mass, that soil mass is coming from the weathering of rocks. What is this weathering? Weathering is nothing but breaking up of a rock into the smaller pieces, smaller fragments, smaller parts by the attack of natural agents. Natural agents. What are those natural agents? Those natural agents may be anything. It may be a wind, humidity, temperature, tree roots, human beings' actions, flowing water, whatever it may be the agent. That agent, when it acts upon the rock, that rock is disintegrated into the parts. That process is known as weathering. Breaking up of the rock into the smaller parts is known as weathering by means of attack of natural agents. Okay, these are known as weathering agents. Clear? Now, observe. If I take up a rock, let us say this is a rock. Clear? And rock is attacked by the external agents. Let us say wind, temperature, yeah, water, all these are the external. Then if the rock is attacked by these external agents, yeah, some reaction happens here. That is physical reaction, breaking of the rock into the small parts. This rock will be broken into the parts, small fragments. This is the soil. Clear? This is the soil mass. Okay? If the agent is breaking physically this rock, that is known as physical weather. If the agents, some chemical agents will be there. Those chemical agents will be acting on the rock. Chemical agents are such as hydrogen, oxygen, carbon dioxide. All these are the chemical agents. If the chemical agents are acting and they are making some reaction here, that is known as chemical weathering. Physical agents are acting, it is known as physical weathering. If the chemical agents are acting, it is known as chemical. But both the agents disintegrate the rock into the smaller parts. Physical agents break the rock into the bigger size of the particles. Hence, coarse grained soils are formed from the physical weathering. Whereas chemical agents slowly react chemically with the rock, and fine grained soil, finer powdered particles are formed. But both are from the weathering process. Is it clear? Agents play a role in disintegration of the rock. Okay, and this process of disintegration, when it is taking, rock is eroded. Rock is eroded. And that's why this is known as erosion. And the eroded mass will be taken away by the same these geological agents to the other place, carried away by the wind, water, etc., to the other place. That process is known as transportation. Then later, those agents deposit the mass elsewhere, layer by layer, like this. Consolidation takes place. Okay, that is known as deposition. Deposition. Okay, deposition. Okay. Again, a rock is formed. Again, it will be attacked after some time. It is attacked by the agents. That process is known as upheaval. Upheaval. So this is a natural cycle. Erosion, transportation, deposition, and up. This natural cycle is known as geological cycle of weather. This cycle is known as geological cycle of weather. That means all the soils are formed by this cycle. Clear? Agents disintegrate the rocks, either physically or chemically. But all types of soils are formed from this process of geological cycle of weather. Is it clear? Now, this soil mass, if I take up this soil mass, having particles and also the voids, exist in some phases. A diagram associated with the condition of soil mass. That means pictorial representation of the soil condition, soil mass condition, is known as phase diagram. Phase diagram. Yeah. Pictorial representation of the condition of soil mass associated is known as phase diagram. Clear? Now, let us simply take up a first condition of the soil, dry soil mass. The phase diagram associated with the dry soil mass. Observe this. What is the dry soil mass consists of? All these are the particles, and these are particles. Clear? And these are gaps inside are voids, as I earlier said. So in dry soil mass, you have only the two things, particles and voids. And inside the voids, you have air. Air is filled. So if I show this by means of a rectangular diagram, simple representation, a rectangular diagram taken. And I have, because two things are there, two entities are there. One is particle, other is voids. I have split it into the two parts. Clear? First is all these are the soil particles I am placing. Heavier the soil particles, downwards I have kept. And the above are voids. Above are voids. Separated. Two things I have separated. And here the voids are occupied completely with the air, and these are soil particles. Soil particles. Clear? Two things. Simple representation. Soil particle being the heavier inside, I have kept down at one place, and voids I have separated. I am keeping on the up. Voids completely filled with the air. Is it clear? No, observe carefully. Left side, I would like to keep the volumes associated with the soil mass. And the right side, I would like to keep the weights associated. So here I represent the volumes, left side, and right side, I would like to represent the weights. Right side, the weights. Clear? Now, observe carefully. Observe carefully. This is completely only the soil particle, hence this entire thing is volume of the soil particles. Vs. V stands for volume, S stands for soil particles. Volume of the soil. And the above thing, year to year, is completely the volume of voids. V stands for, capital V stands for volume, and small v subscription is the voids, volume of the voids. Okay, is it clear? Now, complete total volume is nothing but, for a dry soil, the total volume, capital V, is summation of these two things. Volume of solids plus volume of voids. Fundamental basic. Clear? In the dry soil, we will be having soil particles volume plus voids. Vs plus V. Similarly, if you come to the weight size, this is weight of soil particles, and this is weight of voids. And remember always, in the voids we have the air. Air is having the negligible weight. It may occupy the space, volume it may have, but weight is negligible. We take in the soil mechanics, the weight of voids as negligible, hence it is always still. This is assumption in the soil. That means complete the total weight of dry soil masses. Total weight of dry soil masses, W. Weight of soil particles, Ws, plus weight of voids. But weight of voids is 0, hence total weight is weight of solid particles. or soil. This is the phase diagram. It is a two-phase system since you have only the two entities, particles and the voids. Hence, it is a two-phase system consists of two phases. Clear? This is the dry soil mass. Okay. Let us take up a simple problem associated with the previous gate question. This is the previous gate appeared. Okay. Here I list out the specific gravity, of soil mass is 2.7 and its wide ratio is 0.945. If it is fully saturated, what will be the moisture content? What will be the moisture content in it? How the clarity? First, you look at the problem before attempting the gate question. All are conceptually very strong. So first understand carefully and highlight it. What is given? The specific gravity of soil mass is given 0.7. Void ratio is given 0.945. And E is clearly saying it is fully saturated. Fully saturated means all the voids are fully filled with the water. Then E is asking what is the moisture content. The moisture content. Is it clear? Now, let us solve this problem. We have a fundamental equation. We have a basic equation that gamma bulk is equal to specific gravity of soil mass, GS plus ES by 1 plus E into gamma W. This formula is associated with the bulk density. This formula is associated with the bulk density. This is the fundamental formula. You can solve any type of question with this formula. And another basic formula we have is ES is equal to omega GS. This is also another fundamental basic formula. Both are very, very crucial. Okay. These are two things. First one and the second one, basic formula. If you look at the data given in the problem, what is given? Is given specific gravity, GS, and void ratio given. It says fully saturated and is asking water content. That means second formula is useful in this context. Clear? Now, if we take up ES is equal to omega ds, the formula which is useful out of those two. So, what is the, according to the data, what is the specific gravity? GSE is specific gravity of soil mass. How much it is given? 2.7. And E is void ratio. Is void ratio of soil mass. How much it is given? 0.945 given. And E says soil is fully saturated. S stands for the degree of saturation. Degree of saturation. Degree of saturation. Since it is fully saturated, it is 100%. All the voids are fully filled with water. 100% means it is 1. By default, it is 1. Now, what is asking? He is asking moisture content, omega. Moisture content is how much at this level of degree of saturation. That means, if all the voids are fully filled with the water, at what moisture content those voids are going to be filled? Is clear? Now, let us substitute in this basic formula. Clear? So, ES is equal to omega GS. E is given 0.945. Clear? Into degree of saturation is 1. Omega, we want to find out. GS 2.7. Finally, if you simplify GSEs, after the simplification, that omega moisture content we want is 0.945 by 2.7, which is 0.35. To convert into the percentage, 35%. This is omega. Answer is this. That means at 35% of water content, all the voids are fully filled with the voids. All the voids are fully filled with the water that is fully saturated. Is it clear? Okay. Let me take up another problem. That is another gate question. Okay. A sample of dry soil mass. Be careful, is saying that it is dry soil mass. Weight of it is 120 grams. Is 120 grams. And its volume is 80 ml. 80 ml. If the specific gravity of soil mass is 2.80, the wide ratio of soil is, this is the question here. Have the clarity in the question. He says it is a dry soil mass. Mass is dry. That means only two phases. Particles are there and the voids are there. Complete voids are fully filled with the air. And the weight of this dry soil is 120 grams given. Its volume is given. 80 ml is given. 1 ml is 1 cc, cubic centimeters. 80 cc is given. And specific gravity also quoted as 2.8. E is asking wide ratio. Is asking the wide ratio. Is it clear? No. Just now, I told you that the basic formula is what? Bulk density is GS plus ES by 1 plus E into gamma W. Observe carefully. In this is the basic formula. This is the basic formula. Okay, this is the basic part. Observe in this, what is the soil mass? Given soil is a dry soil. Dry soil means everything is, all the gaps are filled with the air. That means there is no water. No water means degree of saturation is how much? S is equal to 0. So substituting this, when S is becoming 0, then the right hand side of the equation becomes, this term is 0, Gs into gamma W by 1 plus E, right hand side of the equation. And observe the left hand side, bulk density, bulk means totality. Totality becomes what? It is also, this term is associated with the what type of soil? Dry soil. So bulk, the total density of that soil becomes the dry density. That means we denote it as bulk totality. This stands for the bulk, gamma stands for the density. So density becomes dry density. This formula is simply reduced to the this one. Okay, now let us make use of this formula in solving the question. So what is the formula? Gamma dry density, Gs gamma W by 1 plus E. Observe carefully, what are the terms associated? Gamma dry is dry density, and Gs is specific gravity. Gamma W is unit weight of water, fundamental things. E is wattage. He is asking wattage. Now, what is the simple definition of gamma dry? Gamma dry is dry weight of soil mass. D stands for dry. W stands for weight. Dry weight of soil mass by total volume. What is the dry weight given? 120 grams. And what is the value? 80 ml. 80 ml is 1 ml is 1 cc. I am converting gram per cc. So this is 120 by 80. 120 by 80. If we simplify this, 4 3s are 4 2s are, it becomes 1.5 grams per cc. Dry density is how much? 1.5 grams per cc. And you know very well that gamma W, what is the standard unit weight of gamma W? Gamma W is 9.81 kilonewton per meter cube, or in the gram per cc, because here the unit is completely grams per cc. I am also taking standard unit weight of water, 1 gram per cc. This is, we know. This is, we know. Is it clear? This is already standard one. We know. Okay. Now, Gs given, specific gravity term, how much he has given? 2.80. Yes. Clear? For specific gravity, there are no units. It is given. Now, you know, in this formula, you know gamma dry, you know specific gravity, you know gamma W. What else he wants? What? That's so simple. So just substitute these things. Okay, gamma dry, yes, gamma W by 1 plus E. So left hand side 1.5 gram per cc. Calculated value GS 2.80. Gamma W 1 gram per cc. Standard value 1 plus E wide ratio. Clear? 1 plus E. Now, on both sides, gram per cc cancels. Okay. On simplification, 1 plus E, if I take up this, 2.80 by 1.5. Okay. And completely on simplification, wide ratio becomes 0.86. On simplification, wide ratio is 0.86. Is it clear? Oh, you have understood the things carefully. Okay. The basic things we have concentrated. If you are completely strong with the concepts, you can solve any type of gate question, because gate is such a type of competitive examination where concepts should be very strong. If you look at the Indian Engineering Services IES examination, they're not only concept, you need complete analytical skills. That means a series of statements are given. You have to analyze each statement carefully. You can attempt the question. At the same time, one chapter is linked with the another chapter. And there also you need the logic and application in the ES examination. That means for the both gate and the ES, first parameter is conceptually you should be very strong. The second parameter is you should have good analytical skills or the subject knowledge. And the third parameter, very, very important, is practice of the questions. And you must know what to hit a competitive examination, you must know what to read and what not to read. Because in the competitive examination, several factors associated, but the prime factor is that's analysis of complete syllabus and which topic is having more weightage, which topic is should be neglected. You should have the knowledge, but our thrust, our focus should be on the scoring of the marks. Why? Because finally the rank, what you get is associated with the marks. Understand? So hope you have understood the basic concept. I have touched the basic concepts of soil. Simple index problems appeared in the gate examinations. Okay. Thank you. Thank you very much for your patience.